everything else versus Bitcoin essentially gets spent and dies.
I want to be able to have reactive security, and I think OpVault is today the most straightforward, easiest to use way to do that.
I will not be insulted by a clockmaker.
Overall, these kind of ways to make the network easier to both build on and interact with, I think is a really big deal.
If Bitcoin existed when we started Twitter, we would not have to go down the ad model path. I mean, it's simple as that.
Integrating Lightning into a social network is the killer app.
Hello, and welcome to the Bitcoin.review podcast, where we explore developments and projects with the people who actually make them happen. The show is supported by Pod 2.0, Sat Streaming, and CoinKite. If you're a new listener, I'm NVK. I run CoinKite, where we've been helping people secure their Bitcoins for over a decade. We make the cold card and fun products like the block clock. You can find more information about it on coinkite.com. Hello, and welcome back to the Bitcoin.review. Today we have a very interesting show. It's going to be a knife fight. Two men go into a room with one knife, one comes out. On my left side, Rijndael for Team MPC, weighing 64 kilobytes. On my right side, Rob for Team Script with variable sizing, so we don't know. Is this already a loss? We don't know. Let's find out. Hello, gentlemen. Welcome to the show.
Hey, how's it going?
Thanks for having me.
Just so you guys know, there is a bit of a delay already, I can see. So we're going to work with that. So guys, well, let's start here with Rijndael. Can you please give us a little bit of a primer on Team MPC?
Yeah. So, something that you've been able to do in really complicated and convoluted ways for years with ECDSA is you've been able to do what's called multi-party computation, where you have multiple actors or multiple devices work together in order to create a shared public-private key pair and then sign transactions. And this is really useful if you want to have segregated signers or have other kind of multi-party protocols like Mercury Wallet uses state chains. But now that we have Schnorr signatures in Taproot, we have really easy and straightforward signature aggregation, which means that you can do things like have a multisig, a threshold signing scheme, where you have T of n signers required to spend some Bitcoin, but it all squishes down to a single signature on chain, and so it's more private, it's more space efficient, and we can support new protocols that would have been either too cumbersome or too expensive or too difficult to do with Bitcoin script. And so we all need to embrace signature aggregation and lean into multi-party computation protocols for all the cool stuff we're going to build on Bitcoin.
Hey, but is MPC even Bitcoin?
I mean, MPC is a general class of algorithms and protocols, multi-party computation. There's MPC outside of Bitcoin, but now we can use MPC to do Bitcoin things.
Oh, so it's not Bitcoin.
It's still Bitcoin.
Oh, I see. Well, we're gonna find out. Mr. Rob, do you want to give us a primer on Team Script?
Yeah, Team Script has a rich, deep history in Bitcoin, starting in block 170 when Satoshi paid Hal Finney. It's very the Grug brain equivalent of just you have a key, you present a public key, and then you present the signature for it. And it's so beautifully simple. That's Team Script, baby. Just one key, one element on the stack, and it works. And it's been around since the start of Bitcoin.
Hold on. No. So hold on. No, that's not Team Script. You just made the case for Team MPC. If we wanted to do threshold signing in Bitcoin, right now you have two options. You can either do script-based multisig with opcheck multisig, and we should explain what that means in a minute, or now that we have Schnorr signatures, you can do signature aggregation. And in signature aggregation, you have one public key, one signature, and you check it, and that's it. It's like the purest expression of Bitcoin. Rob is trying to get everybody to put multiple pub keys on chain and multiple signatures on chain, and then use a for loop and counting to figure out whether or not your spend is allowed.
Listen,
it's insanity.
This is just your typical NPC, rhetoric. It is absurd. Yeah, okay, you could do even more things. And that's what makes Bitcoin programmable money, right? You could put many things on the stack and you can do different things. And that's what's so beautiful about it. Opcheck multisig just works. And it's a beautiful thing because it's all sitting there on chain. Here's something that, we really, in Bitcoin, we really value the idea of auditability, right? With MPC, you have this weird concocted security scheme that exists off chain, and then you don't even know who actually signed at the end of the day. You have no verifiability, right? You want to actually have accountability of who actually signed that signature, and you lose that all with MPC.
Yeah, but I mean, on the other hand, if you have auditable, recognizable setups on chain, then one of two things happens. Either you have to use one of the really common script setups, right? So you're either doing single sig, or maybe you're doing 2 of 3, or a small number of people do 3 of 5, or you end up standing out like a sore thumb because if you build some really interesting, like, time decaying multisig, or if you end up building some really exotic, 13 of 15 multisig because that's what makes sense for you as an individual or an organization, then that ends up being very identifiable on chain because there's nobody doing it. So, another thing that's nice about Bitcoin is that it's pseudonymous, and ideally just spending your Bitcoins doesn't immediately identify you on chain. And if you have all of these, really exotic key hierarchies in your redeem script, then you're just calling out to the world, here I am, I'm making this transaction right now.
Yeah, but see, you guys are just blabbing now. I wanna hear use cases here, real world use cases, none of this Miniscript pipe dream.
Well, we're even talking about Miniscript yet. Miniscript is its all other thing. So, like I said, you want to understand how Team Script works? It's live today. It's in Bitcoin Core. Block 170, Satoshi sent money to Hal, and that's how Bitcoin's worked for a very long time. This is a really great point, too. MBK, talking about pipe dreams here. Rijndael, what wallets out there right now? You mentioned Mercury Wallet, but like if I wanted to do on-chain MPC, like what does that even look like right now? It sounds like it's a whole pipe dream to me.
Well, I mean, you don't even know because, you can't identify those spends on chain. So they could be happening right now and you would have no idea.
Oh, cool. So like but what wallet can I use to actually do this?
Maybe we should take a step back and explain.
Oh, that was a gut punch. Oh.
Yeah, talking about pipe dreams, man. Like every single wallet, I can. Sparrow uses scripts. Spectre uses scripts. All of the hardware wallets uses script. Like it's all live. Bitcoin Core uses script.
Let's talk about interactivity.
Yeah, let's talk about interactivity. So, the way that Bitcoin script works, if you have to go and set up a multisig, right? So you need to pass around a bunch of xpubs and use that to have everybody come up with script pub keys that you're going to lock your funds to. And then when you go to spend those funds, then you hopefully are making a PSBT and you pass that around and everybody signs it. In a MPC world, it's a little bit more involved. In order to create the script pub key that you're going to lock your funds to, you have to generate a shared public key. And this works a little bit differently in Frost versus Musig, but in general, everybody generates kind of public key shares and pass those around. You add them together, and then when you want to spend funds, you pass around nonce commitments, you partially sign your transaction, and then you pass around those partial signatures and you add them up.
This sounds complicated.
Yeah, but we have software. Software is really good at automating complicated things. So this isn't something that a human would have to do. This is something that your wallet would do.
Yeah, but how is bunker coin people in their bunkers in a cave gonna do this on the wall with chalk?
Well, they're not going to be spending their Bitcoin, so it's fine.
That's then a good point then.
Yeah, and then so I feel like we kind of skipped over a huge piece here, right? Because with the output, like first off, output descriptors streamline the script redemption path, right? It's very well understood now that if you have an output descriptor, you have the necessary information to recover your money. Whereas there's a word, like the key word in this whole MPC architecture is the nonce, right? You mismanage that nonce and you can have an attacker on the inside and money gone, right? Interactivity, like that's multiple rounds of signing and interacting with each other. And those are just, I like to call it foot gun as a service. Is it's just finding a bunch of different ways that you can just make money gone.
We can do this. We had a whole episode on Frost where I think we can store nonces securely and not repeat them. I think it's possible.
Yeah, and like the danger is something for, protocol designers to figure out, right? Like we used to have nonce problems with just normal single sig Bitcoin before, and then we standardized on using deterministic nonces. In multi-party like signature aggregation protocols, you don't want to use deterministic nonces. Instead, you want to pre-commit to them ahead of time by sending around hashes of your nonces so that you can ensure that people haven't change them after they've seen your nonce. But, this is a solvable problem. It's solved in the specs for both Musig 2 and for Frost. And, you just need to follow the spec when you implement it. It's just like writing a Bitcoin wallet, right? Like if you, implement ECDSA and you're just doing like pay to witness pub key hash and you decide to just use like the same nonce over and over again, then money gone. Right, like nonce mishandling.
Well, didn't blockchain.info had that problem?
Yeah, exactly. Like nonce mishandling is just a problem with digital signatures, right? So no matter what you're doing, you have to be careful with your nonces.
For people that don't know, it's a number once.
But I mean, getting back to something that Rob said, right? So I mean, like there's, if you're using a complex script to manage your funds, then you need to handle the availability and durability of your redeem script, right? And output descriptors are a handy way to encode that. But now you have this extra metadata that if you have your funds in like a 3 of 5 multisig and you only have 3 of your keys, but you don't have that output descriptor, then money gone, right? So in either case, there's like some additional metadata that you have to keep track of or money gone.
One part that I don't like about the interactivity is that it has to happen, right? You have to share those nonces at some point. Normally, you'd say when you do the setup, and you have to store them securely, unless we have deterministic nonces.
Well, you have to store them securely, and then there's the metadata you then need to keep track of, right, is the nonce counter, right? So if you start a signing process and you decide to, halfway through, like rotate out, like then you necessarily need to increment your nonce because, and the reason why specifically this is important is that if you have a malicious person in your MPC arrangement and nonces start getting reused, they can start unilaterally signing and taking over the money, removing the security because it's only one public key on chain. So because of that, if they get enough information leaked out from the other parties, they have enough information to construct a malicious transaction and broadcast it to the network.
Have anybody been working on resolving the nonce issue, the unique nonce issue, like maybe deterministically like we do with standard script or something else?
So you don't want to do deterministic nonces, but like people are playing with different mechanisms to not make it be its own round. So if you read like the Frost paper, for example, the way that it's written is you do nonce commitment as like a discrete step. So if the 3 of us were doing a Frost key signing, we would like trade nonces. And then once that's done, then we'd move on to the actual signing step. There's ideas that folks are working on, things like when you do a signing, you, as part of that message, you also exchange the nonce commitments for the next signing. So you always kind of like are ahead by 1.
So you ratchet it.
There's also implementations where when you trade nonce commitments, you don't just trade like one nonce commitment, you actually pass around a big bag of nonce commitments, right? So you say, all right, I have 100 nonces from Rob. And then when we do signing, we just indicate like which index we're using, right? So there's like engineering ways that we can reduce this so that it's not, 2 steps every time you have to sign a transaction.
So what you're really saying is that like this is really cool. We have some ideas, but we're not quite there yet. We're just waiting for some very smart Galaxy brain to email the mailing list saying, "Ha, I figured it out."
I don't even think it's there. Like I think people are implementing it, right now, and it just takes some time to get built and get tested.
Okay. Didn't BitGo add Musig too?
They did. So, BitGo is responsible for a large portion of, value transacted on the Bitcoin network every day. And their enterprise customers can start moving over to Musig too, right? Which is pretty cool. Like we should probably say that Frost and Musig 2 are different. Maybe just to take a step back for people who aren't familiar with the terminology. Frost is a threshold signing scheme. So when you think of Bitcoin multisig, traditionally that's called a threshold scheme, where you say, I have N total keys and I need to sign with some threshold T of them. So I have 3 keys total, I need to sign with 2 of them. I have 5 keys total, and I need 3 of them. I have 999 keys and I need to sign with 998, whatever that is. That's threshold signing. Frost is a scheme using Schnorr signatures where you can do threshold signing, but it all collapses down to a single public key and a single signature on chain. So even if you're doing a 998 out of 999 multisig, it's still just a 64-byte signature on chain and a single public key. So it looks identical to a normal, single sig Bitcoin transaction, and it takes the same amount of space. Musig, on the other hand, is confusingly what in normal cryptography is called a multi-signature, which means that it's N of N. So it's 2 of 2, 3 of 3, 5 of 5, 100 of 100. People probably have heard of Musig before because I think it's what we're going to end up using for Lightning. So, a Lightning channel is normally a 2 of 2 multisig, but it'd be great if that channel open was actually indistinguishable from a normal single sig Bitcoin transaction. So that's using Musig. Another use case for Musig is this BitGo thing, right? So BitGo, if you're like an enterprise customer of theirs, you can be in this 2 of 2 wallet where like one key is cold and one key is hot, and it takes signatures from both of them in order to move the money. And normally with like script-based multisig, you just see these 2 of 2 Bitcoin transactions on chain, and using Musig, it's indistinguishable from a normal single sig transaction. So it just looks like a single key signed.
Do you think the biggest driver for them was the privacy or was on-chain fees? Because the fees were getting pretty high. And traditionally, like, a lot of the Bitcoin brokerages and big enterprise, like, they don't repass those fees to customers. So on on the BitGo case, it's coming from the customer's wallet, so they are paying the fee. So maybe they were complaining to BitGo, the BitGo was overpaying fees and spending their money, right?
Yeah, I mean, it could be, especially if you have a transaction with lots and lots of inputs, right?
Miners.
So if you're miners or exchanges, right, where they've been taking like lots of little deposits and then they need to do a consolidation, you have to provide a valid witness for every input in a transaction. So if you're doing a transaction that has, 300 inputs and each one of them is like a 2 of 3 multisig or a 2 of 2 multisig, then you're providing, for 300 inputs, you're putting 600 signatures on chain and either 600 or 900 pub keys on chain. Right? Versus if it's Musig, then if you have 300 inputs, you're putting 300 pub keys and 300 signatures, right? So it like literally cuts your cost in half if you can do this key aggregation.
There's another context here, though, for the reason that like a BitGo and all these entities use MPC. There's a third option, Rodolfo. It's shitcoin tech debt. Is what it is all of the other coins, they can have one solution that wraps up all of the different cryptocurrencies, whereas they can't use Bitcoin script because they're all, unless they're a fork of Bitcoin, they don't use Bitcoin script. So they're actually incentivized to support all of this because it supports all the other coins.
Do you think that their Musig implementation supports shitcoins? I'm not sure, because we know Firebase, which is the other essentially half of the market for enterprise Bitcoin and shitcoin solution for the exchanges. They use a type of MPC that has nothing to do with the coins. It's just how they secure the keys, essentially. The big one, I didn't read the specifics. I don't even know if they released the specifics. I wonder if it's useful for the shitcoins.
Well, if you do, so there have been some MPC EDSA wallets. I think Coinbase has one in their custody offering, and those are actually useful for other coins that do ECDSA. So Ethereum, right? You could do it that way. Not a lot of other coins do Schnorr signatures. Like the Ethereum ecosystem is leaning really hard into BLS signatures because they're more useful for ZK snarks. So, Musig doing Schnorr signatures is actually not quite as specific as Bitcoin script, but that is pretty peculiar to Bitcoin. That's not going to be portable to lots of other chains.
Yeah, that's what I thought. No, oh, by the way, BLS signatures, aren't those sort of new and shiny and shouldn't be used yet for something like that?
They rely on bilinear pairings, which is much newer cryptography. I think one of the things that the Bitcoin ecosystem is very conservative about is relying on new cryptographic assumptions, and pairings are a new cryptographic assumption.
Hey, we have Adam back chiming in here. He's like, I'm not sure I'd put Musig Frost in the same category as MPC constructs, which in my opinion complex fragile risk of crypto implementation's mistake. The Demgard Jurek base ECDSA construct is a bit complex in itself, though, while not generic MPC, so similar critique for that.
Yeah, I mean, MPC is a really general term, and I think Adam's right, which is that Musig and Frost are much more, I'd say, constrained and much more tightly defined than a general MPC signing scheme. In the really strict sense, they are a multi-party computation, but they are very strict and tightly defined. And one of the things that was interesting about Frost is Frost actually came with a security proof, right? So we have a proof that that Frost kind of reduces down to the same cryptographic hardness assumptions that we normally rely on for Schnorr signatures.
Yeah, I mean, there's an interesting point here too, just to briefly talk about Schnorr signatures, is that they were originally around and available during the Bitcoin white paper, but it had a patent on it. So when the patent expired, they were able to do the part of that upgrade. So it was already tech that was ready to go and people wanted, because it has these better aggregation properties. But talking about the general, you're right, in that specifically Musig and Frost don't really benefit other coins, but MPC as a concept in the industry has been put forward. TSS, threshold signature scheme, is a way to have one security stack which secures everything, which on August 10th at the Black Hat USA conference is going to be a whole breakdown of how the open source Rust and Go language implementations of TSS are actually broken, and with 1 to 2 rounds of signing ceremonies, a malicious actor can break the threshold signing. And this is what I'm getting at, is that it's not secure. Just be a grug brain, put the pub key on chain, and it's going to be okay.
So guys, I mean, it's kind of interesting that we have a wrench thrown in here, which is Taproot, and the capacity of having all this in the same vehicle. So maybe there is a path in which we can address both.
Yeah, I mean, so the thing that's really cool about Bitcoin script, right, is there's a bunch of operations that we can do in Bitcoin. So we can check signatures. That's the foundational one. That's the bottom of everything, right? We can also compare values. And one of the value comparisons that's really useful is you put a hash into your script, and then you provide in the script witness a value, and you say, does this value I provided hash to the same thing that I committed to in my script? And that's called a hash lock. we can also do time locks where we say, is the current block later than this the current block height or has so many blocks pass by, and those are time locks, and we can combine these things together and compose them together. And one of the things that's cool is that Bitcoin script, especially in a post Taproot world, like it doesn't. If you compose a script and you say, I want these coins to be spendable if this signature is valid and it's been 15 blocks and you provide the preimage to a hash, it doesn't really care if that signature is generated from a single key or from a bunch of key shares that then have been added together. And in fact, you can't tell, right? So you can actually use a Frost or a Musig key as part of a larger script. So that's really helpful. Like, NVK, you asked for use cases a few minutes ago. If you wanted to do a time decaying scheme where you say pub key A is good now, but pub key B is going to be good in 3 months. And maybe that B pub key is like a different person, or maybe if you're using Frost, pub key B is a Frost key with a smaller threshold. And so now you can do sort of a time decaying multisig where you say, I've got a 3 of 3, but it, decays to a 2 of 3, and then it decays to a 1 of 3. And you can express that progression of time through different script paths, and then and then your choice is, do I just want to put all the pub keys on chain and pay for the bytes and pay for the privacy? Or do I want to go through a little bit of complexity when I do signing and have it all be single key?
So since, everything can be done together now with Taproot, why don't we switch sides here and make each other's points? Rob, how do you save MPC from losing this battle?
Oh, MPC, this is a really incredible point here, is that every single time you want to rotate out these signers, it's an on-chain transaction, right? But with MPC, you can actually use Frost and you can rotate out who is your 2 of 3 without having to do an on-chain transaction. And this is how we get to scale Bitcoin, right? We get to scale Bitcoin because we get to compress data on-chain, so we're not taking up as much block space, so we can make room for the entire planet to get onboarded. And further, let's say the 2 of us are in a 2 of 3 multisig, and then NVK, you go off into the Canadian woods and you have a boating accident. We can rotate and kill your share of a key and recompute the polynomial such that we can have this without having to move funds on chain. It could be myself, it could be Rijndael, and a third party, right? We'll have Johnny come in and be the signer. And that scales because it doesn't require an on-chain transaction, but we provably can kind of outright do this rotation and change who's holding the key material without ever having to interact with the chain.
Well, this is through Roast, right?
Roast makes Frost more asynchronous and more robust, because one of the things that Rob left out when he was painting this rosy picture of a post-Frost future for us, right? It's so easy to leave out the details, but you know what, Rob? Details matter. Something that Rob left out is that in this key signing ceremony that he's constructed with Frost, if you have a malicious signer who just decides you know what, I'm just going to hang up partway through the signing process, then you force everybody to have to just start over again. And if you're doing 2 of 3, that's not a big deal. But if you're doing a really high cardinality threshold, then it can actually be really disruptive because you have these interactivity requirements. And maybe if one of the signers is running bad software, you can actually force them to reuse a nonce because they think that they're still part of an old signing session. So what Roast does is Roast makes Frost robust against signers going away or refusing to cooperate by basically running a whole bunch of signing sessions in parallel.
Is somebody mowing their grass?
Yeah, that's me. Sorry.
Nice. Okay, guys. So I think we get to a point here where I still defend the fact that I don't think, Frost is ready, but I don't think anybody does. We did a whole Frost episode, which people should really listen to.
Yeah, I mean, one of the things that's just great about script, right, is you can do, multi-sig constructions in script today, they work. The auditability point is a good point. Like something with Frost is if you wanted to do, let's say it was like a 3 of 5, and all of a sudden the money moves, you can't actually look on chain and see who signed for it. Whereas with like a script-based multi-sig or having a script path, you could. So, in that scenario that Rob just painted for you, like he and Johnny might go and steal all the money, and you won't actually be able to prove that they're the ones who signed for it.
Thinking just sort of like pragmatically here, in terms of enterprise, it does look like having multi-sig with some of those keys being Frost is more interesting, because now you can have sort of like groups, right? And the groups are provable on chain. So at least you have some auditability on the signing that happened.
Technology moves over time and it progresses and there's evolutions, right? Just because today we don't have these things doesn't mean down the road we're not going to be able to do this. And I want to build for a bright orange future where everything is a single sig on chain. Don't have to worry about it, right? Like there's no need to do all the complication stuff. Like it's just adding extra pieces on chain, and if the chain doesn't lie, you have much more flexibility to kind of orchestrate all of your security procedures off chain, because that's not dealing with the consensus mechanisms, and it's much easier to get to a scalable final answer if it's all just being done off chain and you put as minimal information as possible on chain to actually execute your transaction.
Question for you guys. Do you guys know what that new wallet from Block uses on their, because they have some kind of like threshold signing in terms of like spending capacity. So that means to me that they must have something, or is that just like business logic?
To my understanding, it's a 2 of 3, right? You have a key on the phone, you have a key on the hardware wallet, and you have a key in the server. And to my understanding, it's a 2 of 3 logic. And then the server is able to implement kind of business logic, right? And this is like a whole point about being able to govern some rules off chain is you can have certain spending limits, right? You could have frequency of spending and amounts of spending, and the server is able to enforce that to help protect users.
Okay, so it's just a standard multisig.
Yeah, we don't. There's been a bunch of conversations about covenants all over the place, including on this show. And something that would actually be really great is if we had some transaction introspection opcodes. Because like one of the things that you cannot do today in Bitcoin is you cannot say, hey, I have a 1 Bitcoin UTXO. Yes. Half of it needs to go left and half of it needs to go right. If we had enough of a covenant to be able to do output introspection, to be able to like look at the amount and the script pub key of the outputs of a transaction, then you actually could, send to like a pay to script hash type output that said, only this amount or only up to this amount can go to these addresses, or can go, anywhere if I sign with particular keys.
It gets even more interesting, right? If we had a way for transactions to know the amounts, you could have time locks on thresholds, which really, really makes stuff interesting, right? Because now you can have spending velocity, which is like one of the most useful things that HSMs offer.
Absolutely. Yep. And you could use this all over the place where you say, hey, I've got my mobile wallet, and this is exactly a spending velocity use case, but just to say it for the people who are still awake. Hey, I've got my mobile wallet and I can spend up to $100, but then I need to co-sign with my hardware wallet if I'm spending above that. You'd be able to do that and have it actually be enforced at the consensus layer of Bitcoin if we have covenants. So like that's the kind of thing that we could do if we had something like CTV.
But the current covenant proposal upvolt does not. Well, I mean, they did expand upvolt to have CTV as part of the package, didn't they? And CTV does provide the capacity of this introspection.
Mm-hmm. Yeah, I think you might be able to do something similar with APO. There's a trick to to be able to get the transaction hash on chain. And then I think if you have opcat, you could like construct the transaction in your script and then do a comparison. But it's a lot more moving
Doesn't
parts.
opcat bring recursion back?
I don't know. And like, frankly, I don't think that that's actually a bad thing. Like, people get freaked out about recursive covenants and they say, oh my God, this is going to turn into Ethereum. I think the original sin of Ethereum is actually global state and reentry. It's not recursion, right? Because like, we can have bounded recursion. Like we have script op limits, right? So we could do a similar thing. I don't know.
Well, they don't have UTXO, so they can't really go to any granularity there, right? Like they have to check the whole script to know what the account balance is. So like just the amount of computation you need for that. Like, I mean, I feel so bad for the exchanges that support Ethereum and all its contracts. Like, I don't think people appreciate how insane it is to keep balance.
Yeah, I mean, it's pretty nuts because like the way that all these token contracts work. So like if you have either an NFT or like a fungible token in Ethereum, the way that it works is like your account doesn't have a balance of that token. What happens is that token's contract has a little hash table that lists account IDs and then the token balance. So if Rob wants to know his account balance, what he has to do is he has to look at every token on chain and then see what his balance is with that token and then add it up. So it's this big scatter gather. So what ends up happening is a small number of entities run giant indexes that just invert that index. And instead of saying, what's your token balance per contract, they say, what's the token balance per account? And like, that's why, all these Ethereum wallets hit like the same API endpoint because they have to build this giant index and track the whole thing. It's absolutely insane.
I was looking at Bitcoin Optech, as I often do, to go deep in the weeds on stuff. And this is where another option of T-Love, right, becomes an option: tap, leaf, update, verify, where you actually can have amount introspection become part of the logic of the tap leaves for like how you're spending things. And looking here, it says it would require an additional opcode, but then you would be able to do this too, which is basically a different approach of trying to have this covenant-like feature. Yeah,
and I mean, like, just kind of pulling it a little bit back more towards what we were talking about earlier, right? Like the thing that's so cool about Taproot, and hopefully if people are still awake, they understand this about Taproot, right? But like the thing that's magical about Taproot is snort signatures and then masked, right? So, if you have a really big complex Bitcoin script, usually the way that most contracts or most protocols work is it's like, okay, if everybody agrees that this is what we should do with the money, then like we should just do that. If not everybody agrees, then there's a bunch of conditions and there's like a set of ors between them. So, if we don't all agree, then Rob gets the money if he can provide the pre-image to this hash, or Rijndael gets the money if he can sign with a particular key, or NVK gets the money if it's been 6 months and nothing else has happened, right? Like that's like a common way to construct complex financial transactions. And so what you can do with Taproot is you can say, all right, we're going to take all of those script paths. So like Rob does the pre-image, Rijndael does a signing, or NVK just waits until a timeout happens. You take those three scripts and you put them into a Merkle tree. And then you take the root of that Merkle tree and you add it to a pub key that would be like if the three of us took all of our pub keys and added them together and got a single pub key out of it. So if we aggregated our keys together, then that's the we all agree case. So if all of us agree and we just like sign, then that's a key path. If we don't sign, then we descend into this Merkle tree. And so you can have kind of like the happy path of it's just a normal check sig as like the key path. And then if you need to descend down into the tree, then you only reveal the like kind of script component that you're actually using. You only pay for that in terms of block space, and you only reveal that in terms of privacy. And like that's Taproot, right? And it's a way that you can kind of do all of these things.
Yeah, it's the best of both worlds. And additionally, something that's may not fully understood, with Taproot, they actually got rid of opcheck multisig, because opcheck multisig is a for loop and it's very computationally inefficient. Whereas in Taproot, to do a multisig, you do opchecksig add. And then you just add up the signatures, and either it's a 0 or a 1, right? Is it a valid signature or not? And then you get to the end and you compare it to what your threshold is. So it's computationally more efficient as well. And additionally, with the Schnorr signatures, you can, as we mentioned earlier, since you're using Schnorr signatures in Taproot, you can have a single public key on chain, and it's actually its own aggregated T of N behind the scenes using Frost, or an N of N using Musig too.
So, I mean, it sounds like the real like best case scenario is that we actually build, a tree of script leaves for the different spending conditions that we want, and then within those script trees, those individual leafs, we use aggregated signatures to save space and to make it more efficient to check.
That sounds like a reasonable compromise.
Yeah, so why don't we do that?
I don't want to hear compromises. Just kidding. For the folks listening, I'm having a terrible fucking connection here. It's hard to keep track. So anyways, guys, it's fascinating that we went like everywhere and also like managed to cover a lot in only 45 minutes. Where do we go from here?
Well, I mean,
there you go.
Yeah, I was going to say, like, I think, what's cool is that with Taproot, we can construct addresses and construct wallets where, in kind of the happy path, like when you're just spending your money, it just looks like a single sig on chain. And whether that's actually a single key behind it, or if it's like a Frost or a Musig aggregation, nobody really knows or cares except for you. It's just your business. But then if you want to do something really complex, like you want to have a time decaying multisig, or in a post covenant world, if you want to have, like a amount based spend conditions, or if you want to have like key hierarchies that have like hash locks or time locks attached, then you get a script, and you only like reveal that script when you actually spend it. I think one of the problems, in addition to just like this stuff is complicated to build, is that there's a handful of exchanges and wallets and Bitcoin ATMs that don't support pay to Taproot yet. So if Rob goes off and builds like a really kick-ass Taproot wallet that has all these really advanced features in them, but people can't get their coins into it out of like Coinbase, then, like a whole bunch of people aren't going to use that wallet, and it's going to be a big question about whether or not Rob wants to like lean on those features in the first place. So I think, something that we need to do is we need to get exchanges and other service providers to support pay to Taproot like today. Taproot came out more than a year ago, and it's a few line changes for most people to be able to support pay to Taproot. They have to be able to correctly parse Bech32M addresses. There's a website called whentaproot.org, and it lists which exchanges support Taproot and which ones don't. And that doesn't even mean like receiving Taproot, just pay to Taproot. And it's literally like a 2 or 4 line change. So I would encourage everybody to like go on that website, find your exchange, and if they don't support pay to Taproot, you should open support tickets or blow them up on Twitter and say, when can I withdraw to my Taproot wallet?
Yeah, just to name and shame, the remaining ones are Binance, Binance US, Bitfinex, Coinbase, Crypto.com, Fireblocks, Gemini are really like the big ones left. Venmo and PayPal too. But to your exact point, there's a very different architecture requirement to like receive Taproot, because you need to have all that code. But just to send to a Taproot address, it's just checking a checksum. It's not involved code, and it doesn't incur tech debt or complications to being able to custody and manage funds.
I mean, but like, guys, we don't like, I mean, that's important to have, but like, this is not like, the thing holding us back, because, most people who are playing with these features and, companies who are playing with these features, these users will probably have a hop in between the exchange. They're not going to send from their exchanges to whatever they're going to do directly. By the way, we see sometimes people paying from an exchange to an invoice and can take a day or two for the exchange to process the payment out.
Yeah,
So,
it's nuts.
Yeah, so like,
for sure.
I don't think that that's the bottleneck. I think the bottleneck is just that like this shit is complicated, and I don't think people are seeing the like 10x, 100x sort of like immediate magical upgrade in UX or in price or in anything really, and that's sort of like what's really holding people back.
Well, I think it goes to just starting to build out these features, right? In that, I directly like was starting to mess around with mini TapScript. The reality, though, is to Rijndael's point, like to build a wallet that can't receive funds from Coinbase makes it like a hard wallet to interface with. It's not everything, and I think part of the path forward is leading by example and having these features available and being able to show a better way of doing things, and then kind of setting a standard to have people want to try and catch up, to try and improve, the user experience. And that's the thing, is that end users, like just someone who's, just holding their Bitcoin, they bought some Bitcoin, they don't care about all the fancy expressiveness, but it's our duty as people that are building in the space to try and show that they don't even realize like the possible upsides in being able to support these features, and just being able to make it be the first mover, get it out there, get people playing with it, and then over time kind of like shifting the mindset of what's possible in Bitcoin and leading by that feature set.
I mean, to me, what really is going to drive this home is, somebody out there makes a very cool app, phone wallet that does something that is interesting and new and is sort of like super efficient somehow, or does something that was not possible before, and everybody wants that feature for whatever reason. And that's how you get it. Like that's how adoption gets it. It's like something goes in the market that's just like remarkably better than everything else, and then everybody starts switching to it and starts like, I wanna put my stuff in it, right? That's how you get the demand to happen.
Very fair. Yeah, that's hopefully some of the stuff I'm working on right now kind of starts doing that, having Bitcoin have more flexibility in doing different things. You're not going to see these upsides if everyone's just doing N of M multisig, because N of M multisig is good enough with pay to witness script hash, right? So you need to start kind of expanding the design space without doing a soft fork, right? Like there's 117 opcodes that are active right now in Bitcoin out of the original 256. Like the Miniscript stuff that I'm doing like uses like 20 of those opcodes to try and do some really interesting things. But I've started rotating out of being a Miniscript influencer into now being a paid to Taproot Beck32M influencer, just to get like I went back and forth with Coinbase. I had to go through 4 levels of support just to have their specialist support team tell me that Taproot was enabled in November of 2021 and they still don't support it. So just getting like gently nudging them on that side while also putting out good products that make people want to use these advanced features.
So like on the custody side, that like, it's like sort of a companies. Why is it that Nunchuck, Casa, and Unchained don't have it, right? Like, because they would be like, to me, the first sort of like the assisted sort of like more company like kind of entities that would be the first people to have more interesting Taproot solutions.
So for Casa specifically, Nick Newman was on the Galaxy Brains podcast, and he said specifically the Miniscript stuff is really interesting as an added feature set. So I think they're starting, they've already like, I don't know if they're actually at the second building on it, but it's definitely caught their attention. And I think people are now just starting to realize this opportunity. So there's gonna be a little bit of a lag because companies have roadmaps and obligations and deadlines of existing things. So you have to go into some sort of like quarterly sync up of like what's the next set of features you add for the next quarter, right? So there's gonna be a little bit of a lag, but I see, a year from now, there's gonna be multiple companies that are gonna be implementing this for more advanced custody use cases that better empower users to manage their money on their own terms.
Well, and we have Liana Wallet, which is doing a bunch of stuff with Miniscript, mostly for either an inheritance use case or like a backup key use case, right? So after some time lock expires, you get to use a different key. And I'm pretty sure right now that's all just like normal, pay to SegWit, pay to like witness script hash. I wouldn't be surprised if in the not too distant future they end up like moving to Taproot, because I don't think, those users are going to want to reveal their whole spend policy every time they do just a normal like happy path spend. And so I think we're going to see a lot of stuff like that where people kind of start with SegWit script hash encumbrances using like Miniscript or using something else. And then they end up moving to Taproot because it gives them more compact and more private spends. And then, as like Musig gets more widely available and as Frost gets finalized, I think we're going to see people start incorporating those also. Like Nick Farrow has a project to actually do like a Frost hardware wallet on like commodity hardware. It's like super early, we'll see how that goes. We talked about, some Musig deployments that are like already seeing production right now. I think it's just very early for a lot of this stuff, but I'm, cautiously optimistic that it's going to start rolling out.
The challenge that I see with like something like Liana is that like, essentially UTXO rotation is a no-go, right? Like, so it's like, it's like dead on water. So like until we can overcome those issues, like, it feels like just sort of like jerking off.
Yeah, I mean, like the thing that would be useful, because like in order to solve that problem, you have to do one of two things. You either need to have like a server that does key deletion and you do like a vault setup with pre-signed transactions, or we need covenants that support vaults, right? Whether that's opvault or something else. If we had like an actual covenant opcode, then you don't need to do UTXO refreshing every 6 months or something. Maybe what does...
But hang on a second, like you can't do server key deletion, right? That's like pointless because it's not provable and it doesn't end well. Like, I mean, realistically speaking, at least in my view, it's like we can't move on from this impasse until we have covenants on chain.
Yeah, I think that's right, but maybe this is just like helping prove out demand.
Nobody's gonna use it if they have to rotate their UTXOs.
Yeah, that's probably true.
So this is an interesting third way, just as opposed to like key deletion or waiting for the protocols to get updated. I've been debating usability of this, where you can use end lock time to basically pocket a pre-signed transaction, and then you can auto broadcast like the refresh later, right? So you
but
just
still,
as a quick just to quickly explain. No, so just to quickly explain, the difference though is that like at a script level, like you encumber the like using opcheck sequence verify or opcheck lock time verify. Those are at the script level tied to the UTXO, whereas an end lock time lock is locked to the transaction level. So just for the people at home, for the one or two people still awake, is that with an end lock time, it's almost using end lock time for a time lock. It's almost like having a check and post dating it. So if I wanted to like send Rijndael a check, I could say like, oh, this is only available in December 31st of 2023. So it's sitting there, it's ready to go, but then it can't be broadcasted earlier. And then you sequence that so that it's before the time lock like threshold expires. And then you can just auto broadcast the transaction hex then. And the network won't look at it until it's ready to actually be broadcasted.
You still have like a you're delegating the interactivity requirement to somebody else, right? So instead of you having to come online and rotate all your UTXOs every 6 months, you say like, all right, I'm going to have the server rotate all my UTXOs every 6 months.
Yeah, no, you do have an interactivity because you have to actually hit it to the network when it's ready to go. You can also have paid services though that like provably like when they broadcast it, you could find some sort of ways of monetizing where I think Pablo built something like this where he would hold your your transaction hex for you, and then it would broadcast at the set time, and he'd get paid over Lightning or something to be able to like manage that service. And then you could give it to multiple services because you only need one person to actually successfully broadcast the transaction for it to work.
Sure. I mean, like the real answer is covenants, right? But I think I don't know. I hope we don't end up in a chicken egg scenario where people who are pro premature ossification say, oh, we don't need this because look, nobody's using wallets that would depend on these features, but then nobody wants to use those wallets because we don't have covenants, right? Like that's the
prisoner's dilemma,
chicken and egg scenario that we're probably going to end up with.
Yes and no, right? Because you're going to get a false negative, right? Because nobody's going to use these wallets that require UTXO rotation. So I rather not have the false positive than to simply say, you know what, like we believe there's demand and, we're going to build it and we're going to USF it. Wait, did I just say we're going to UASF
You did.
confidence?
You did.
Oh boy, did I just start something?
Yeah, that's going to wake everyone up if they were asleep.
Yeah, no, I really think that it ought to be done at some point. I think we need to see something that essentially everyone feels overconfident about in terms of a proposal, and then I think the gears are going to start to move.
Yeah, I mean, it's kind of funny that it's like an accident of history that we don't have covenants.
Mm-hmm.
Like, we turned off a couple of opcodes. Otherwise, we would probably have the kind of functionality that we want. Or, the one that always I think is always funny is like we have, for folks who are APO fans, like we have sig hash none, but we don't have sig hash, any prev out. And so it's very like asymmetric. And I think if you were designing all the sig hash flags from a blank sheet, you would either have both of them or none of them. Like it's weird that you can commit to an input and not an output, but there's no way of committing to an output and not an input, right? Like that it's very asymmetric. And so I think it's strange that we don't have covenant mechanisms in Bitcoin.
And I don't remember. I mean, my memory is already failing on this, but like I don't remember any opcode that was deactivated that could have done something like that. But this is way back, or any sort of like work on anything like it in the Satoshi days. There was op evolve, but that was a disaster, and that was Gavin. That was Gavin.
Yeah, right. So there's like you can there's a trick to get the signature of the current or the hash of the current transaction onto the stack, and then if you have opcat, you can construct like here's what all the outputs should be, here's what all the inputs should be, and then you hash it, and you should get the sig hash, right? So like you can use that to do like a really basic covenant.
Yeah, and for all of these different opcodes, I usually look to like, and we talked about this on the Bitcoin script project, like episode that we did with Alex. Like, there's almost like a two-dimensional, like the kind of the feature richness of a given opcode, and also like how production ready it is. Like, is something like a white paper, or is it actually like implemented code, right? So CTV, like Jeremy has all that code sitting there, right? Another one that's related to all this is like check sig from stack is already in the elements. It's like the blockstream chain, right? So like it already has working reference code that could be audited, right? And then you go out further on the end that like simplicity, where things just get like so many diffs and so complicated, right? It's a much wider swathing thing. And I think the idea, should be, it's incumbent on people that are looking to try and like push the edge here to champion their solution and put it forward. And I think like what James is doing, like with Op Vault, it's a great concise way of like a very straightforward functionality that I think no one would disagree that they wouldn't want to ideally have some sort of warm staging area before your funds just go out wildly, into the ether to someone else, right? Like there's a lot of opportunity.
I think stuff like Elements kind of does a disservice, right? Because it's amazing stuff, amazing tech, no doubt. But the problem is it's like, almost 100,000 diff, right? Like it's not going to get merged, period, ever. Right?
No.
Like,
you would never have to merge everything. Like there's a difference between like simplicity and everything versus like just op check sig from stack, right? Like you can take a small chunk of that whole thing.
I don't think you can.
Okay.
Like if I remember right, like with Elements, I think was all or nothing kind of thing. And if they wanted to split a little part off, it would be like a whole other sort of like project to try to get that in.
Okay.
It's not, if I remember, it was not that simple, but it's been a while since I looked. But anyways, like my point is like, I think, it's very hard to get everybody behind a single standard, right? XKCD has the best cartoon on that.
So
right?
good.
So I don't know, but I have a feeling that the trend is changing, and like even folks who are pro-ossification like me are sort of like, we need something. Yeah, I'm hopeful. Guys, is there anything else that we sort of like forgot to explore in the knife fight between MPC and TeamScript?
I I think we hit everything. I'm not sure if there's anything that you had, Rijndael, on your side. This has been a very fun shitpost war to have something fun to actually talk about in the bear market as opposed to price models. I'll say that it's been a pleasure being in the knife fight with you.
Yeah, thanks. You too. Yeah, I mean, like maybe just the thing to hit is that, if you can actually have both, right? So if the thing that you're trying to do with your script is express like optionality or time or possession of some other secret value, then you're going to use like a script construction for that. And then for the actual like threshold or multiple key part of it, today, Bitcoin script is kind of what we have. It's like what's widely deployed. It's what we have code for. It works. But, there's constructions for doing key aggregation that, work. We have software for it. They just haven't found their way into many wallets yet. And so as that happens, we'll be able to get like cheaper, more private transactions that we can also like build new, better protocols on top of, right? So like being able to compose things together because they think it's just a single signature. So it's probably not actually an or. The future is probably Bitcoin script and key aggregation, not Bitcoin script or key aggregation. But yeah, Rob and I were just really, 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 really tired of the Bitcoin Twitter drama, and so we wanted to start some new drama.
Yeah, I mean, I really that was very refreshing. Very high signal posts with proper memes too. It was very expertly executed, and I hope it continues.
It'll continue. This isn't over.
Please don't stop. We need competitive green checkbox tables, comparison tables.
Yes.
Those are always winners. And like I think necessity is gonna drive governance and the stuff home, because when we get to the next ultra high fee environment, I don't think it drops to the levels that are in now. I think it's gonna be something that's gonna be a wake up call to people. Especially if we have like a third world country, high populated people sort of starting to actually adopt Bitcoin either via Lightning or on chain. I think shit's gonna get weird. And the Lightning companies, they need to close those channels, right? So they are going to be pushing a lot of the stack too, because it's in their interest to make the block size, the block space be used more efficiently, even by the people not doing Lightning, or they're out of business.
Absolutely, yeah. And then the covenants too unlock things like coin pools and sharing UTXOs. It just makes it more feasible because like the scaling conversation is, you have a set throughput that we made in the block size war of how many transactions can be in a block. We weren't going to increase the block size and ruin the decentralization of the network. And so because of that, now you need to find other creative ways to allow people to have a way to claim on-chain ownership of funds. And your options are have it all sit in custodians, or do we build better cryptographic primitives that give some level of security assurances on-chain? And it gets really interesting. And just before I forget, just like a huge shout out. We mentioned the Frost episodes every time. So a huge shout out to Jesse Posner and all the work he's doing with Frost. Specifically, like fingers crossed that getting merged into the SEC 256K like ZKP library later this year is like one of those bedrock things that allow the application layer devs like myself to actually be able to start going in and playing with these primitives and starting to push through like these user experiences and like wallet experiences that can push forward better ways of using Bitcoin.
Well, I mean, if it's not on libsec, it's not going to get used. Like, that's, to me, the threshold these days on how I look at some of this stuff. It's like, and not even the ZKP, right? We're talking about, like, actual Mother libsec.
Yes.
Mother libsec is essentially, I think, the best sort of heuristic of, like, should be used, should not be used. And it's, like, sort of, like, nice to have things like that because it prevents people from losing money.
And everyone uses that same library. Yeah,
that's right. Yeah, no, it's very cool. Rob, do you wanna like tell us a little bit about Trident and what you're working on?
Yeah, so Trident is the name of the wallet I'm building at Anchorwatch. Trident, great name by my co-founder Becca, was like the idea of multi-pronged security, right? And we're leveraging Miniscript specifically, right now we're using pay to witness script hash to be able to embed more interesting custody arrangements on chain. And the whole crux and thrust of what we're trying to build is actually having a product that we can actually underwrite risk for to provide insurance. Because today in the custodial landscape, you have custodians that charge management fees, and maybe they have one insurance policy that's covering all of the customers. But if there's a catastrophic loss, you're not really on the hook for anything, right? So if you're gonna have to give up your keys somewhere, like having better like legal financial protections to actually indemnify you in the case of a loss, which has its own kind of back-end complexities. But the tech part that's really interesting is using these more advanced scripting arrangements with time locks, right? And we can use, for the length of your insurance contract, let's say, we at Anchorwatch are a required signer. And then when the insurance contract expires, you can just go and take your money. So you don't have to worry about calling a custodian and saying like, hey, can I get my money back? And then, you know, the other person on the other side of the phone is like a Prime Trust or an FTX or a Celsius, right? You don't have to like, this is a way of like giving the on-chain auditability to show for a fact that your funds aren't being moved around maliciously and that you're ultimately able to get access to it. So like it's a different way of kind of expanding the design space of how Bitcoin gets used today as programmable money to ultimately better serve customers. Our primary focus are going to be commercial entities at first, but you have the Wizard Sardine guys, which are using Liana Wallet, which is kind of a similar idea for more robust backup situations. And the ideal state is moving this also all over to Taproot. Our whole tech stack's built on Bitcoin Dev Kit, which is really a superpower insofar as having a really strong set of primitives built on, I'll use the right term, crust Bitcoin and crust Miniscript.
Thank you.
Right. And having these like baseline level tools, which are really robust. So when it becomes a conversation around like, hey, we want to add coin control, or hey, we want to add, tap scripts, like we're not re-architecting the entire tech stack from the beginning. And most of it is very modular. It's a very powerful programming primitive. So just another huge shout out to just the Bitcoin Dev Kit team, all of the maintainers, Steve Myers, Alikos, Danielle, like Thunder Biscuit. Like there's a whole crew over there that are just grinding along. And it gets really exciting too. And also just like shout out, like another example of like just the power of BDK very quickly is just like the Mutiny Wallet guys are, working on BDK, and they were able to take their progressive web app and just push it into an Android app because the BDK library has bindings for all of the apps. Like, so you can build something in Rust, and then you can push it over to Swift for iOS or Kotlin for like Android, and you don't have to re-architect an entire different code base. So it's an incredibly powerful, robust programming tool. And I see a future where like everyone uses, the Sec256 like library, like everyone's just going to start using PDK as like a default Swiss Army knife. So you're not building a wallet in step one, doing elliptic curve cryptography and finite field theory, right? You just have everything just works.
Well, I mean, like Bitcoin is becoming complex enough now that like back in the day, I'd say it was already a bad idea for most people to write a wallet. Nowadays, it's definitely a bad idea for people to write a wallet from scratch.
Yeah.
Unless like they have like some serious people in the dev team that are very specialized on this, which there's very few people. So leveraging something like this is very similar to leveraging something like libsec. It gives you the correct primitives, the correct way of building the scripts so that people don't lose money, because Bitcoin kills you on the edge cases.
Yeah, and the thing that we want to cut out here is undifferentiated heavy lifting, right? So like in Rob's application, the thing that's special and unique about Trident Wallet is the spending policy. Like he's not trying to innovate or push the envelope on like coin selection, right? So being able to just say like, all right, I'm just going to use the coin selection algorithms that come with BDK. Like he doesn't need to go and become an expert in, branch and bound or like whatever the new thing is. Like they just use what's in BDK. So yeah. Rob, in your system, like the thing that you were describing of you guys are a cosigner, but then after a time lock it decays. I imagine that you could also do kind of like a key hierarchy, right? Where maybe it's like, oh yeah, like like maybe you guys are always a required signer, but then for one of the other signatories, like there's some optionality of it's like, it's always you guys, and then it's either like party A or party B, and then it's always two of parties C, D, and E, something like that.
Yeah, and this is where it gets really interesting is like in a traditional just like N of M, like multisig world, one key represents one vote. Whereas with Miniscript, you can break it out and have multiple, let's say 2 of 3s, right? So me and AnchorWatch can have a 2 of 3, the customer can have a 2 of 3, you can have third party 2 of 3s. And this then means, and that's not a 6 of 9 to be clear, you get to have not only across multiple institutions distributing risk, but individuals within a company or organization, like, you know, in theory, like you could have a CoinKite quorum where like Rodolfo's key must sign. And then it's like, if you feel spicy enough, you want to let Vic hold a key, Vic can hold a key, but he can't rug you, right? Like that gets like a much more interesting arrangement where you can encode these governance processes of a key hierarchy where in a company setting, you don't want all of the keys to be equal. Like that's insane to have all the keys be equal. But at the same time, you don't want the CEO to be a single sig, right? So you can distribute your risk out this way. And it gets really interesting in like redesigning and rethinking like how does security work in Bitcoin, and with organizations, we can have more interesting ways of encoding this.
I mean, ideally your script mimics your organization's business logic, right?
Exactly.
Processes,
right?
Yeah.
Ideally, that's what you have, right?
Yep.
But Bitcoin, you know, is Bitcoin, and you know, it can't do that yet, or it can't do that specifically like that ever. But we can definitely get closer to that. Maybe especially with CTV.
Yeah, no, definitely with CTV, you can encode all of those spending policies and limits, but it gets it closer rather than having an, and I got this like mental model actually talking with Will Cole, like application versus protocol level security. Like you could do this on an application layer, but then it, like you can still end run it at the protocol level of keys leak. But
see, this is the problem, right?
Able to
like,
mirror it, yeah,
you can't, right? Servers get hacked.
Exactly.
And like the way, a lot of times, the way these things get done is by breaking the HSMs that have the spending policies, right?
Yeah.
Like that's how you get hacked a lot of times, right? Dev keys get leaked, and then they go and they change the policies. Because if somebody can change the policy on the HSM, it means that the bad guys will find a way to do the same, right? But you can't change a script. That's the beauty of using a script as the HSM.
Exactly. No, that's exactly it, right? So when you encode it on chain, you don't have to worry about a server doing the logic at the application layer. It's on the blockchain. So there is no end running around like, you know, these different processes. So you can actually like insert the human element, you know, go slow to go fast, so to speak, right? You want to be very deliberate, and you can put human governance in between these like signing processes. So you're not just indiscriminately using the HSM with a policy, blind signing things as it comes in. And if it gets compromised, you lose your application security.
Well, let's make every problem be a key security problem, right? Not a computer security problem.
Exactly.
Well, yeah, and you know, like the stuff that we can enforce in script is limited by what we can express in script, which is why we need more complex opcodes. But I mean, like Rob, like that example was probably a really good one, because you know what you guys are saying is, all right, if you have multiple organizations that all have shared custody of some basket of funds, then you know, like for your signing, you're going to rely on whatever internal controls you have, whether those are like technical controls, policy controls, like a combination of the two of them. But then, you know, you still have some consensus level enforcement of like, all right, you know, 2 out of these 3 organizations have to sign, right? So it might be that like within one organization, somebody's able to get escalated privileges and like sign a thing that they aren't supposed to, but that doesn't necessarily mean money gone, because you still have to have, you know, somebody else in another organization sign for it, right? And so you're kind of using multisig, you know, to control the spend across organizational boundaries, but then you're relying on whatever internal controls people have, like within.
That's exactly
boundary.
right. And what's really interesting, like, I mean, at the moment, since we're not using NPC for anything, we can specifically, like, someone can hand us a transaction. We're like, hey, you know, your VP of sales signed this transaction. Like, was this supposed to happen? And you then know for a fact, like, which key got compromised, which helps just like with auditance and governance checks, right? And like having multiple bands of communication to kind of verify these things in a way where you're not ultimately this human element is so critical for making sure that, you're doing things the right way. And you have this audit log, which is the PSBT of which signatures are currently present.
So in like a post-Frost world, if you guys did this naively and you just said, all right, we're going to do everything with with like the key path on Taproot, and it just always looks like single sig on chain, then you'd lose that auditability. And so if you wanted to keep that auditability, you'd have to do something like have a tap script for each, combination of signers, and you'd get kind of the auditability by looking at the control block and like which tap leaf got revealed. Or there's a Greg Maxwell idea floating around out there that like you do a bunch of tap leafs, and then on each one you have one of the signers just like have their own signature, and they act as like a coordinator. And then you have everybody else aggregate their signatures together. Yeah. So each tap leaf ends up looking like 2 of 2 using like check sig add, like you were talking about earlier. And one of the signatures is like an identifiable party, and then the other signature is like a Musig or a Frost. And so you're like literally doing script-based multisig, but one of the signatures is actually an aggregated signature. And so you kind of get the best of both worlds, where it's like 2 of 2 on chain, but that second key might be, 15 of 20 or something.
Yeah, it gets really interesting too. So just as a quick note, when you're doing pay to witness script hash, you're committing to the entire script path, right? But with the tap leaf, you're just committing to that tap leaf. So you could have, 100, 1,000 tap leafs, each with the right combinametrics of each different party in theory. And then you have this auditability to your exact point. And then you don't have to worry about someone taking the signature and repurposing it later for something else like you would with pay to witness script hash, because you're only committing to that specific tap leaf.
Would it be a challenge to pre-compute this?
That definitely would get more challenging, but I'm talking in a future state where the tooling has already kind of been largely figured out.
Yeah, because like you do commit to all of it. You have to pre-compute all of them, right. And then you use the root of the Merkle tree to tweak your internal public key.
Is there anybody working on some more advanced stuff like this already? Like that's like out there as like prototypes, scripts?
So you mentioned earlier, right? Nick Farrow is working on this new Frost-like wallet, Rijndael, like starting to get this tooling out there.
Yeah, or if people want to see really weird Taproot script construction programmatically, believe it or not, the Ordinals project, Ord, like that wallet has like a very unusual tap script embedded in it. So if you just want to understand like what does it look like programmatically to build up a tree of tap scripts and then use that to generate an address, that's actually a really good source to go and check out.
Yeah, it's a wide open space of opportunity. And one last thing that also gets really nice with tap scripts versus pay to witness script hash, specifically with Miniscript, you can't have a duplicate public key in the stack. And that means you have to generate many like child like derivations. If you're using a signer, like let's say it's a 2 of 3 and then it becomes a 1 of 3. Like if you have different branches, you can't use an identical public key. So the way this works right now is that you can generate a different account for each one. But if it's all on Taproot, you don't have to worry about a duplicate public key ever happening. And you're able to just have it in the tap leaf. So you only have one account that you need to manage ever for a given signing device, which is definitely a better UX perspective. And it makes it much more straightforward. It's all, yeah.
I got bit by that. Why can't you have duplicate pub keys in Miniscript?
Oh, yeah. So you can't have duplicate pub keys because within the same script stack, because when you sign it, you can't prove that someone isn't going to like malleate the transaction and have that signature for that pub key appear in a different branch. And it also breaks the composability. It breaks it's a common sub-expression issue. That's me just repeating a word that Andrew Polstra said without me fully understanding the technical ramifications of it. Yeah, right. Like that's a good oracle to use.
It's usually a good strategy. Yeah, for sure.
But Miniscript policies are also composable, right? So that's the idea too. I think it breaks down the composability. If I'm say using this pub key in a different branch, like then you start having collisions, especially if it's pay to witness script hash, then like if you're signing, like if the key appears multiple times, that signature is valid for the whole stack. So it violates the malleability aspect of things.
That makes sense.
Yeah.
Yeah, because like with Taproot, that wouldn't be an issue because you only reveal, just the leaf that you're actually using, and then the control block. So for folks who, for the one person who's still listening at this point, the way that you spend a Taproot script is, we mentioned earlier that like you take all the scripts that you want to put into your tap tree and you make a Merkle tree out of them. So when you go to spend it, you provide a little data structure called a control block that includes like a Merkle proof. So it provides like the sibling hashes like all the way up the tree back up to the root to prove that the script that you're spending was actually like included in that address. So, because you have this Merkle inclusion proof that commits to a specific location in the tree, somebody couldn't take that signature and like play it in a different branch of the script because you haven't revealed the script.
Exactly.
Yeah, that makes a lot of sense.
Yeah, guys, I kind of got dropped, but I think I'm back now.
Everyone's falling asleep, including Rodolfo, who fell asleep, and now he's back.
Man, it's hard to do a podcast as a host with bad internet. So, okay, guys, I guess the last thing here is, Rijndael, what are you working on that you can talk about?
I'm working on using interesting Bitcoin script constructions to help people with more interesting custody setups. So I'm pivoting hard into TeamScript and working on custody tooling.
Okay, no specifics we can hear about the tooling.
Not today.
Okay, fair enough. Rijndael is a mysterious man.
That's right.
So guys, I mean, listen, thank you so much. I mean, we have almost 2 hours. We went from like, having the topic almost finished in 30 minutes, but then not, but then yes, but then not. I think it was fantastic. I think that if people are not asleep to the end, they're going to get a lot of signal here. I think you guys did a fantastic job. I need to declare a winner. And the winner is Elon Musk for rugging my connection again.
Yeah, this is, congrats, Elon. You deserve it. This was kind of like the emergent shit posting, just like Twitter banter was, damn it, we're going to make everyone learn about Bitcoin. And what was great. We started seeing meta memes of people watching the debate and seeing that there's a lot about Bitcoin people don't know about. And that's what we wanted to have fun and a nice little drama wrapper, have people start learning more about, how Bitcoin actually works under the hood and getting people to think about like the opportunities of solutions and products that can be built on top of more advanced scripting and MPCs.
Yeah, I'd love to see more fake drama around really obscure Bitcoin topics. Like maybe the next beef is maybe we can get some like package relay, like meme warfare started. That'd be pretty cool.
Ooh, I love it. We didn't even talk about the Taproot annex. Like, that's just like...
Or we should dig the version, the original client, Satoshi original client, and start showing all the poker code blocks.
That would be awesome.
And say that Bitcoin was designed to be poker or something. Start some like weird conspiracies too. That always helps. Listen, guys, thank you so much. Any final thoughts, Rijndael?
No, just be the memes that you want to see in the world. There's lots to do in Bitcoin, so go play with new stuff.
Rob.
Yeah, it's a bear market. You should be building and learning about Bitcoin. You shitpost about price in the upswings, and in the downswings, you shitpost about the tech, and then you're always going to be happy in your lane, moisturized, happy, content. That's what you want to be.
Flourishing. Yeah, no, my favorite meme of your fight was the one where it's like the frog sort of extended a hand to the guy on the floor, and like one guy is like super sad, the other guy is like winning. I can't remember. It was
it was like the guy that was sad. It was like drive chain arguments, price things, SEC, FUD, like all these things, and then the guy that was happy was like Musig, Frost, Miniscript, Taproot.
That's right.
It was just why in 2023 are we talking about stock to flow and price model, guys? Like, let's just move on.
No, I mean, the best part is everybody's an expert on clawbacks, right?
That's right.
And now everybody's an expert on superconductors.
That's right.
That's right.
By the way, I am starting a pod, the superconductors.review. I have the domain, and I'm gonna have some Bitcoin experts weigh in on the superconductors because Bitcoiners know everything, and Bitcoiners are always right about everything. So
NVK, so the here's the format for the podcast. Every week you come on, you do your intro, and then you say, "Has anybody reproduced the paper?" No, and then you turn off the podcast.
that's that will be very successful. I mean, I should add some ads on the beginning.
Yes.
Yeah.
By the way, that material, the LK99 medium stuff, is very easy to make. You just need a small kiln that sells on Alibaba.
Oh.
And I'm certain that people are going to do it.
Yeah, there was like this random guy that had like an anime avatar in Russia, and he was like doing side-by-side step reproductions, and like it's accessible enough, people are just going to start running off and trying to do it.
I support home labs.
Absolutely. The favorite detail, though, I thought you would have picked up on that meme with comparing the two. I posted in the chat here is the Barbenheimer meme. You know, you have the pink cold card and you have the black cold card, and you have to choose a side. Which one are you? I saw
that. I actually did see that. That was something.
That was American Hodl's idea. American Hodl said you need to do the Barbenheimer meme with the black and pink cold card.
Where does the glow fit in?
We'll have to figure that out. Glow in the dark. I have to get a glow in the dark one before I can properly assess the vibe it has. Right.
Listen, guys, we're going to do this again, either with the next drama or with the expansion of this drama, because I don't think the Bitcoin script versus MPC drama is ever going to go away.
It's never going to go away.
No.
Oh, I just can't wait for the CT. We need some CTV drama.
Oh, yeah.
That'll be fun. Yes. I missed the CTV drama. Okay, guys. Thank you so much. Thanks for putting up with this atrocious connection and my incapacity of participating too much. Maybe that's why I made it better. So you guys have a wonderful day. Thanks for listening. For more resources, check the show notes. We put a lot of effort into them. And remember, we don't have a crystal ball, so let us know about your project. Visit bitcoin.review to find out how to get in touch.